Okay, I'm going to start here. I'm going to keep going with the chain rule today and work a couple of more complicated problems. Okay, let's start with f of x is equal to the cube root of x squared minus 1, that quantity squared. This looks a little more complicated, but let's use one of the strategies we've used before when we just had powers of x. We know we got a cube root, we've got a square, so let's rewrite that as a rational exponent first. So we've got f of x is equal to x squared minus 1. Now the power goes on top. The 2, that's the numerator. The root goes on the bottom. So this is really to the 2/3 power. Okay? Now then, once we have that, here's our inside function. And here's our outside function, this 2/3, if you will. Okay, so let's write those out. Inner function, the u is equal to x squared minus 1. And the y, this is on the outside, is that function, that x squared minus 1 we called u, to the 2/3. All right, let's take their derivatives. Let's take dy du. Let's do that first. That's equal to, okay, we take the exponent, put it in front, so we've got 2/3. We'll just keep it u for right now. And subtract 1 from 2/3, which is negative 1/3. Okay, let's go over here and now do u. Let's do du dx. Now that's, well, it looks like it's just 2x, right? Put the exponent in front, so the derivative of this is 2x, the derivative of the 1 is 0, so there's nothing to add here. Okay, so let's look at our whole function, the f of x. So we'll call f of x y, so we'll have dy over dx is equal to dy du, so 2/3. Now we're not going to put u in here. We want the function we call u. So it's that x squared minus 1. So we place that in there. And now we got the negative 1/3. Okay. Now we take the 2x. All right. Well, that is the derivative. It's not very pretty, so we've got to do a couple of things to make it look standard in a good way, okay? So we can take this 2x and multiply it by the 2/3. So we've got 4x over 3. And this part right here, okay, this has a negative exponent. So let's write that as a fraction. Okay, so the denominator is 1. We don't have anything up there. Times the cube root of x squared minus 1. Now we could write this as a cube root or write it as an exponent. It really doesn't matter. We'll write it as an exponent. Clean this up just a little bit more, and our derivative dy dx is equal to 4x all over 3 quantity x squared minus 1, so we'll put that in parentheses, the 1/3 or the cube root. Okay, let's back off this just a little bit so you can see it. Okay, so we started with the cube root of x squared minus 1 quantity squared. We rewrote it the rational exponent. So we took the power here, that goes in the numerator, we took the root here and put that in the denominator. Our inner function is the x squared minus 1. The outside function is that x squared minus 1 to the 2/3 power. We took derivatives of both of them. In this case, we put the 2/3 in front and subtracted 1, so 2/3 minus 1 is the negative 1/3. And then we put them together. 2/3 u to the negative third times the 2x. Here, we started simplifying. We put the 2x and the 2/3 together. We put this, resolved this negative exponent and wrote it as a fraction. And then put everything together so it looks nice. And this is our answer. All right, let's take another look. Let's write, let's do another function. F of x, another radical. Let's do, again, a cube root, if you will. We have 2x cubed minus 1, and that whole thing to the 4th power. Okay, again, we could write this with a rational exponent. So our inside function is that power's on top, roots on the bottom. Now, if we didn't do this, you might see this as this function inside this function inside this function. So you can see by writing this as a rational root, we at least skip one of those steps. It's not always possible, but I believe in trying to do it the simplest way we can. So let's take a look. Okay. So our inside function, this u, in this case, is 2x cubed minus 1. And the y then is a function of u to the 4/3 power. Okay, taking the derivatives, du dx. Oh well, that negative 1 goes, that doesn't always happen, but maybe in another example. dy du is equal to 4/3 u. Now we're going to subtract 1 from that, so 3/3 from 4/3 leaves 1/3. Now putting it all together, dy dx. Okay, so the dy du, so we got the 4/3. We're going to replace the u, the 2x cubed minus 1 times now the derivative of du dx, 6x squared. Clean that up a little bit. We've got 24x squared over 3. Oops. Forgot the 1/3 power up here. Sorry about that. That certainly should be the 1/3 power. And this times 2x cubed minus 1 to the 1/3 power. Let's clean that up a little bit. Let's simplify. All right, so dy dx. 3 goes into 24 8 times, so I've got 8x squared. And there's not really much we could do there. We could change it back to the radical, the cube root of 2x cubed minus 1. And there we have it. Okay. Going back up here. This is what we started with. Broke it into the inner function and the outer function. Took the derivatives of each. Put them together, replacing the u with the inner function, 2x cubed minus 1 here. Then we got all this, we put it together and simplified a little bit. Anyway, that's all the time I have in this video. Until next time,